Today we are going to talk about graphing inequalities. We have spent some time learning what each of the four inequality symbols mean, and we have practiced writing inequalities. Now we need to see what they look like on a graph and apply that. The goal of the graph is to graph the solution set. If you will recall, the solution set is all the values that will make our inequalities true. So with a graph, we want to model which values will make our inequality true. So let's start with greater than. When I have a greater than, I'm going to have an open circle and it's going to go to the right. For example, if I have the inequality x is greater than 1, that means that x can be anything larger than 1. However, it cannot be 1. 1 is not part of our solution set, although that is where we will begin. So we put an open circle on 1 to start our solution set. Now, to help us remember which direction we go, we plug in both numbers to either side of that 1. So for example, 0, let's plug in 0. 0 is greater than 1. Well, that's false. So our solution set cannot go to the left. If I plug in my 2 and say, okay, 2 is greater than 1, that does make it true. And therefore, my arrow demonstrating where my solution set is will go to the right. For less than, we also have an open circle. This time, however, our arrow is going to go to the left. In the example, x is less than 1. Once again, 1 is not part of our solution set. 1 will not make our inequality true, so we leave an open circle. I can go ahead and determine which direction my arrow goes based on the numbers, again, directly to either side of the start of my solution set. So 0 is less than 1. That is true, whereas 2 is less than 1 is not true. Therefore, my arrow will go to the left. Next, I get into my greater than or equal to. In this case, we have a closed circle. But our arrow still goes to the right, just like in greater than. Now, for example, if we have x is greater than or equal to 1, 1 is still starting my solution set like before. However, now 1 can be a solution. If I plug in that value, substitute it in, 1 is greater than or equal to 1, 1 is greater than or equal to 1, that does make my inequality true. So I close it, I fill it in, and that shows me that 1 is where we start our solution set and can be a solution itself. Again, to remind myself which direction my arrow goes, I can plug in, substitute in both numbers to either side of the start of my solution set. And in this case, 2 is greater than or equal to 1 makes my inequality true, meaning that my arrow goes to the right, meaning any number to the right of this start of the solution set, any number to the right of my 1 would make my inequality true. Lastly, we have less than or equal to. Again, this is going to be a closed circle, but this time it'll go to the left. If we have the inequality x is less than or equal to 1, that means that our solution set starts at 1, but 1 this time is also a viable answer for x. It is a possible value. So if I said 1 is less than or equal to 1, that is true, so I fill it in. Again, I check either number. 0 is the value that'll make this statement true, meaning that our arrow goes to the left. So we're going to practice using these. This is just a handy little guide for you, a little cheat sheet that I do recommend you start off using. But then I do challenge you to try and quiz yourself and try and move away from it and kind of work on understanding the reasons why the graphs look the way they do. So let's try a couple of example problems. When we graph inequalities, there's a couple of questions that we can ask ourselves. So the first one is, when I look at my inequality, I want to say, okay, where is my circle going to go? So where does my solution set start? And that would be right at that 4. So that is where I put my circle. Regardless, I'm going to have a circle, so I can put it there right away. So where is my circle going to go? Well, it's going to go at positive 4. Then I need to determine if my circle is going to be open or closed. Well, I need to look at my inequality for that. And here there is no equal, so it cannot, plugging 4 in, substituting 4 in, will not make this inequality true. So I leave it open. Then I need to determine if the arrow will go to the left or the right. So again, I can look to both values to either side of my 4, and I plug them in. 3. When 3 is substituted in, we read 3 is less than 4. Well, yep, that's true. And then 5, if I were to substitute that and double check, 5 is less than 4. Nope, not correct. So that means that my arrow is going to go to the left. So to draw my arrow, I can just make a line like this. When you're using a pencil, it's kind of hard to see. So we do like when you kind of make that zigzaggy line just to really emphasize where that line is. So that's it. You ask yourself, where's your circle going to go? Is your circle going to be open or closed? And then will the arrow go to the left or to the right? And then you go ahead and build it. Let's try 3 more problems together. When we are doing this, we don't actually need to write out the entire number line. So I'm going to show you kind of what your expectation is as we solve this. So we've got m is greater than 3. So what I'm going to do is I'm going to draw a number line. In the middle of it, I'm going to put a 3. That's because that's where my solution set starts. I don't really actually need much more than that, but if I want to put the little numbers on either side of that 3 to help me with my arrow, I definitely can do that. Okay, so I'm going to leave it for the time being. I ask myself, where is my circle going to go? Well, it's going to go on 3. Is it going to be open or closed? Open, because there's no equal. And then I need to determine which direction it'll go. Because this is a greater than, it will go to the right. So I draw my arrow, and that's that. Let's move on to the second one. And again, my problem reads z is less than or equal to negative 14. Negative 14 is where my solution set begins. So that is all I have to graph. However, in this one, I'm going to go ahead and graph negative 13 and negative 15 to remind myself and support myself in answering that last question. Okay, so I always put a circle here because that's where my solution set begins. I ask myself if it's going to be open or closed. It'll be closed because it is equal to. And then I determine where my arrow goes. Well, in this case, I want it to be less than negative 14. I have to then look to the left and to the right. And I know that negative 15 is less than negative 14. And if I substitute it in for z, that's the solution. That's the value that'll make my inequality true. So I go ahead and shade to the left. One more example like this. Y is greater than or equal to 0. So once again, all I have to put is that 0, although you definitely can do more. That's where my solution set will begin. This time it will be closed because 0 is a solution. It is going to make my inequality true. Greater than, I know greater than, numbers going to the right are greater than, so I'll go ahead and draw that. So when we are graphing inequalities, we will use these 3 questions to support us. We've got one more type of problem to go through, and that is pulling an inequality from a graph. This time we do have questions to support us as well. So we're going to start by saying, okay, this is my graph. This is my already done graph. So I ask myself, where is my circle? Well, my circle's at 4. So my solution set will begin at 4. I'm going to go ahead and put my variable in right away also. I always in these situations want to put my variable on the left. As soon as I move my variable to the right and flip these around, things are going to get a little bit messier. So as we are learning, I want us to make sure that our variable is always on the left and then our value is always on the right. Okay, that always goes here. All right, so is your circle going to be, or is my circle open or closed? Well, it is open, so I do not have an equal. And then is my arrow going to the left or the right? Well, it's going to the right. If I plug it in, 5 to make that true, 5 is greater than 4. Forgot to answer my questions. So that means that we will have a greater than sign. So since it's going to the right, it will be greater than. Let's do one more together, and I will send you on your way. It says, once again, we start with where is your circle? So I can go ahead and plug my variable in right to begin with. And where is my circle going to go? Well, it's at 3. So I can put that 3 in right away. Is it open or closed? Well, it's closed. So that means I will have that or equal sign. And then is my arrow going to the left or the right? Left. Everything to the left is less than my current number. So therefore, I've got a less than sign. So when I'm going to go ahead and pull an inequality out of a graph, I kind of do the reverse of what I did when I was graphing my problems, graphing my inequalities. I still find where my circle is, but now I write it rather than draw my circle. I ask if it's open or closed, and then I determine if it's going left or right to determine what symbol I'm using.